So there are three most important elements that you have to know in a game setting, which are players, strategy, and payoff. Players are the people who are involved in this game, and strategies are the actions that the player can choose. And by choosing strategies, the players can get respective payoff. After knowing the components of a game, we can move on to a simple game setting, which is the static game with complete information. In this simple game setting, we have two players, players 1 and player 2. Player 1 chooses an action, lowercase a1, from a set of feasible actions, uppercase a1, with payoff u1 and consists of the action of player 1 and player 2. Simultaneously, player 2 also do the same thing. Player 2 chooses an action from a set of feasible action, and he has his own payoff function as well. And to be noticed, since game theory analyzes situations in which one person's behavior affects the payoff of the other, so in our payoff function here, the payoff function of player 1 consists of its own action as well as the action of another player, and this is called the interdependence. So in general, game theory is concerned with how rational individuals make decisions when they are mutually interdependent. So comes to the most classic question in game theory, prisoner dilemma. We have two players, suspect 1 and suspect 2, and suspect 1 can choose from be quiet or think. Suspect 2 also can choose from be quiet or think. And to continue with this setting this prisoner dilemma game, we have some very important notations that I want to go through with you first. So firstly, we have to know what are the sets of all possible strategies and what is the strategy profile. So a set of all possible strategies combine all the possible actions of one player. So as I have mentioned before, each player have two possible actions, which is be quiet or think. So a set of all possible strategy is just the combination of these two actions, quiet or think. And for player 2, it will be the same, quiet or think. And the strategy profile actually combines all the possible actions by all the players. So for here, it's very simple. We only have two players. So firstly, if player 1 chooses to be quiet, player 2 can choose to be quiet also. So this is one of the strategy profiles. And player 2 can choose think when player 1 chooses quiet. And oppositely, we have player 1 choose think, player 2 choose quiet, and player 1 choose think, player 2 choose think as well. So in this game setting, we have 4 possible strategy profile. Another very important notation is the payoff function. As I have mentioned, in the game theory, the most important characteristic is the interdependence. So my utility, my payoff will depends on my action and the action of another player. So for example, I choose be quiet, and player 2 also choose to be quiet. So the payoff function I get will be 2, 2. And if I choose to be quiet and player 2 choose to be think, the payoff function then will be 0, 3. So after knowing what's the payoff function, we can move on to the most important concept that exists in the game theory in the course of strategy, which is Nash equilibrium. So a strategy profile A star is set to be a Nash equilibrium of the game if for every player I, the payoff is greater or equal than other possible payoffs, given the fact that other players stick to their actions. So in other words, Nash equilibrium exists when an action profile with the property that no player can do better, given that other players stick to their actions. So other players' action won't change, and you have the action profile which can give you the maximum payoff. So let me explain the Nash equilibrium in a game context. Again, we are using the game of prisoner dilemma. So for example, I'm suspect 1 and player 1. By knowing that player 2 will play quiet, I will choose between be quiet or think. So I will compare my payoff. I will get payoff of 2 if I choose to stay quiet, and I will get a payoff of 3 if I choose think. So definitely I will choose think. Same apply to if player 2 choose think. I will choose think because 1 is greater than 0. So I will choose think. If now I'm the suspect 2, I know suspect 1 will choose quiet, and I have to choose between quiet or think. And then definitely I will choose think because it gives me a higher payoff of 3. And the same theory applies to if player 1 choose think. I will choose to play think instead of quiet because I can get a higher payoff of 1. So in this case, very simple and straightforward. Our Nash equilibrium is when both players choose think. However, interestingly, the Nash equilibrium is not sufficient in our case because there is another strategy profile, quiet, where both players would have a higher payoff of 2-2 instead of 1-1. So optimally, both players should choose quiet because they can really maximize their payoff in this case. But the Nash equilibrium in our case is 1-1 instead of 2-2. So we have to notice that we have to realize that Nash equilibrium is not always efficient. And this concept, this principle is very fundamental, is very important for you to deal with harder, more difficult questions later on.